All right. So I'm going to take this hole that's in the protractor and I'm going to put it on the vertex. The vertex is B for this one. And then also, so see how yours might have a line. Mine has a line that's broken up. You want to leave this on the vertex and rotate it to where this line lines up with one of the rays of the angle. In this case, it's the one on the bottom. And then this is going to point up. It's going to start at, starts at 0 and then goes 10, 20, 30, 40. And it's going to point, it's about 44, I would say. I don't think it's quite 45. But if you put 45, it wouldn't really be wrong. Because it kind of give people a margin of error about a degree either way. I'm just going to say 44. Because I think it's in between 40 and 50. Another thing that I want to point out, this is not 130, or 135, it's not 145. This is an acute angle, starts at 0, so we're using these smaller numbers here, okay? It's about 44 degrees. Okay, and then for this one, I really would like for you to measure it yourself to see if you actually know how to do it, see where you're at. You will have to turn your paper in order to either turn your paper or turn your protractor in order to line it up with this line on the bottom here. But still, the hole goes on the vertex. Hopefully you have measured it yourself. I did it this way. If you did the other way, you should get the same answer, so don't remeasure it. But notice how this is not lined up exactly. I've got to twist this and turn it. Because if it is off, even just by this much, that can change it by 2, 3, 4 degrees. All right. So this is going to now start with the outside numbers because this is an acute angle. It starts at 0 here, 10, 20, 30, 40, past 50. It's about 53 degrees. If you put 52 degrees, if you put 54 degrees, that's fine. I think it's about 53, but you may not have put it exactly what I saw because it's definitely easy to mix these up. All right, what we're going to do next is we are going to talk about some constructions. We are going to measure some more angles down here. Notice neither one of these were obtuse. We are going to measure this, and you will have practice measuring an obtuse angle. But we are going to construct this perpendicular bisector. Before we do this, I'm going to just show you the steps of what you did yesterday. So this is what you did on the computer yesterday. We're now going to do this with the compass. And I'm just going to click through the steps and let you guys kind of watch it, and so you have an idea of what it's going to look like with the compass. So step 1 is you're going to take the center of the compass, you're going to go past the midpoint. All right. Step 2, you're going to draw a large arc using that compass. You are then going to move this, and we'll do all the steps together after. You're going to then not change the radius. See, so it says keeping the radius the same. You're not going to open or close the compass at all. And you're going to move it to the other vertex. And then you will draw another line. I guess I can let it do that. Yep, draw another line. And then through those intersections, you have a perpendicular bisector. So this line cuts CD in half, because bisector means cuts in half, and then at a 90-degree angle, because that's what perpendicular means. So let's do this. So I'm going to take, so for those of you who have, I have both kinds, I have both of these up here. So those of you, this is like the pencil part for this one, this is the needle. You're going to put the needle on one of the points, and if you have this one, obviously this is the needle and then this is the pencil. So you're going to place the needle on one of them. You're going to close your compass or open it to where it's past the midpoint. Doesn't matter where past the midpoint, just you want it to be past the midpoint. This also doesn't have to be a really dark mark. It just needs to be visible. All right, so I made my little arc. It's not super dark. But it is important that this stays in the same spot. So if this is opening and closing really easily, you might have to hold it with this hand. Or you could also pinch it up here to hold it. But I like to hold it here on this needle and then just twist it side to side. kind of whatever you feel like is working for you. And then you're not going to open or close it at all. You're not going to change the radius. You are just going to switch over to the other vertex and draw another arc. And then you kind of have like two half-looking fish things. Little fish tails. Now I'm going to grab my protractor and I'm going to draw a line through those two intersections. It might not be perfect, and that's okay. But we have a perpendicular bisector. These two halves are congruent to each other. Like this is directly halfway in the middle. It's easier to see on the next one, so I'll wait till number 2 to show you that. As far as the measurements go. For number 2, we're going to construct the perpendicular bisector. If you already know how to do it, you can just go for it, but I'm going to show you on here as well. You will have to open up the compass a little more because it needs to go beyond halfway. The more you open it up, the further down it goes, so it may touch the words on the directions below, above or below, and that's fine, depending on where you have it. I'm going to leave mine sort of shorter, just beyond half, and that way it won't go as high and low. But if yours does, it's no big deal. And I'm going to switch over to the other vertex. I'm going to draw that second line. That's all you do. It's not too crazy. Alright, we have that. It's at a right angle. We can use our protractor to measure this. And this is 2.5 inches. And it should intersect, it should cross right there at 1.25 inches, which is exactly halfway. So E to that midpoint, EM, is congruent to the midpoint to F. And then also it is at a 90-degree angle, so if you want to test that, you could just look, you can just place this on the line and it should point right up there at 90 degrees. Will there be some human error? Absolutely. Like mine is slightly off. It, you know, goes a little bit to the left, and that's probably because I didn't get this right on the intersection. But that's how you use these. All right, let's go on to the next. All right, here's the steps for angle bisector. You're going to put your needle on the vertex, and then you're going to open up. It doesn't really matter where you open it up to, the circle. It says set the radius to anything. Draw an arc through one side. Then draw an arc through the other side with the same radius. Then you're going to, just like we did before, you're going to pick up your compass and you're going to put it on the marks that you drew. I guess that's not what we did before. Never mind. You're going to just pick it up and put it on the marks that you drew, and you're going to make a mark on the inside of your angle. Move it, make a mark on the inside of your angle. And then you can put your angle bisector there. All right, let's try. So for this example, I'll use this other one. Some of you guys have these. I'm going to take my needle and I'm going to put it on my vertex, which is L. And then right here and right here, I've got my marks. And I lift this up. I don't open or close my compass at all. Then I move my compass to my mark that I made, and in the middle, I can mark I make marks just in the middle of the angle, because where those marks intersect, that's where that bisector will exist. So I'll use my protractor. I will draw my line. All right, and then that's what it looks like. So if you look here and we measure this angle, it's backwards. This is about at 63 degrees. So it goes beyond 60, it goes about to 62, maybe 63, something like that. It's probably more like 62. And then if you look, that angle goes just, that we drew, it goes just beyond 30 degrees. Like just barely. It kind of looks like it's between 30 and 31, which is right about half. So like if the total angle is 62, and each of these are 31, so the whole angle, I don't have other points here, so I can't really, and then each of these are 32, that, you know, shows that these are an angle bisector. Okay, let's measure this one first because it is an obtuse angle, so I just want you guys to see this. Make sure you know how to measure obtuse angles. We're going to put this on the vertex T, right here. And then we're going to look and see how much this opens up. So notice, you look at it, it kind of looks like, oh, this is 60 degrees. But it is not 60 degrees because this angle is greater than 90. So you start here at 0, and then you go 10, 20, 30, 40. You go past 90. It goes to 120 degrees. So angle T equals 120 degrees. So this angle bisector, and it doesn't matter where you start. Start at, well, the needle needs to be on T, and then open it up however large or small you want. And then once you've made your 2 marks, you lift up your needle and you place it on one of the marks. And then it needs to just go in the middle. So make sure you don't put it up here, this mark, because it's not going to be where this intersects. Move it over here. And voila, we have an intersection that we can mark from the vertex to that intersection, and hopefully it's right at about 60 degrees. I think that one may be off just a little bit because I think it's a little bit to the left of the vertex. But we can look, or of the intersection. Yeah, it's pretty close to about 60 degrees. So that would be halfway, 60 on this side, 60 on this side. The total would be 120. Both of these are 60. These angles are congruent to each other. And we just did that by making 4 little marks with this compass and not even with measuring it. That's pretty much it.